So this is the first video in the series of videos in which I be covering upon the basics as well as implementations of every types in the Solidity. So yeah, I hope that you stay tuned with all those videos. So let's get started. Let's go to the slide second. So this slide means that what exactly does Solidity is, right? So first thing first, the language itself is object-oriented language. When I say object-oriented, it means we can easily manipulate the code, and it is essentially used by a lot of languages like Java and JavaScript. A lot of Ruby is also using this. Even C++ is also have the same model. And maybe if you may have heard of JavaScript, most of the thing in JavaScript is said to be an object, right? And I can easily manipulate a lot of code. It is very usable when you have a complex data, a complex code. So then this usability issue comes to the picture. Then we have the statically typed and high level language. So statically typed means if you look at Java or JavaScript is basically a dynamically typed language. So you can easily change the values once you declare them. But in this, you can't change that. They are statically typed. You can't change that. Once you declare, you can't change that. Then we have, it supports a lot of libraries and user-defined types. So libraries, you can import libraries on top of your code. And let's say if you we write React, in React, just go to the top, you just install your, I would say, library with npm or maybe a yarn, and then just import the library on the top by using import command. Just the same as this in this Solidity, it's basically you can just import a certain URL for your library. Let's say OpenZipling, its most popular library, which you can use. You can see me using a lot of time in the upcoming videos. You can import that on the top of your this code, and they also have user-defined types. A user can define a certain type of types, and this basically the same. Then we have easy learning curve. Maybe like easy learning curve. When I say easy learning curve, it's very much similar to Java and JavaScript, because everything in this in Solidity is it's really easy. You can easily touch upon the basics and maybe like intermediate concept of Solidity maybe in the week, right? And you can easily brush up the entire advanced stuff in a month, right? If you be consistent, if you learn on a daily basis, right? That's how easy it is if you are already familiar with a lot of other languages like Java or maybe like JavaScript. And last point is essentially it's very much influenced with Java, JavaScript and C++, and it's also supports library and it's kind of all stuff. Now the next slide which we have right now is how does the code of Solidity is essentially run. So the code of Solidity is essentially run on a certain type of machine, which is also known as Ethereum virtual machine. Now this set of machine, you can think of it like a bunch of computers who are, let's say, just built on top of Ethereum, and you can think of it like a lot of bunch of computers who are bunched together on this Ethereum network, right? That help us to execute the transaction, and these are the same. Then once we write a code, let's say we just write a code, let's say console.log. It's essentially the type of JavaScript. When we type a code in maybe like console.log, and then that code is essentially converted into a bytecode, and then that bytecode is going to be understandable by the machine. Then it shall show us the result on the console. That's how the basic code of this certain language continues to works, right? So that's how familiar with JVM, Java virtual machine. It's also the same. It's almost the same, right? But that works in a centralized manner, but this works in a decentralized manner. Cool. So next we have. So I just prepared this design for you. This is essentially a certain type of network. You can think of like an Ethereum network, and a lot of computers are connected to each other, and these are basically in decentralized manner. There are billions of computers who are connected in this Ethereum network. It's just a small example of how things kind of used to work, right? So this is a person who are requesting a certain transaction, and if he's requesting a certain transaction, he need to pay a certain type of gas fee. Now these computers are decentralized, but they essentially run by miners who helps in processing a certain type of transactions, right? So to reward them, you need to pay an extra sort of gas fee that then distribute among the different sort of your miners and etc., right? Once you pay the transaction fee or maybe like gas fee, your transaction is approved, your transaction is executed by the miners, and then they return a response that your transaction is successful. If you pay higher gas fee, then your transaction would be fast, and your execution would be fast. Now this is the simplest concept. Now just move ahead. Now next thing, we have two components in the Solidity file. So when you compile your file, there are two things that are generated, right? The first thing is your bytecode, and second thing is essentially your contract ABI. So let's understand both of them one by one. Now the first thing first, we have bytecode. So bytecode is essentially it's non-human readable, but machine uses this to show the output of the code, right? So if you think of bytecode, bytes are certain type of function like the 0, 0, 1, 0, 1, 0, 1. But in the case of Solidity, it uses hexadecimal values. Maybe the value goes to F, right? It may be like 0, 1, 2, 3, 4, and also includes maybe like letters to A, B, C, D, and all to F. That's the compilation of entire things done to show the output of the code. And it's used by the machines to then show us the output. And now if you look at this, I also show a certain type of example over here. If you're familiar with JVM, it's also used the same mechanism to do the same stuff for us. Now move ahead. So this is the example of bytecode. Now bytecode is essentially, if you look at this, this is your EVM bytecode. Looks like this. There are a lot of hexadecimal values, as I already mentioned that. So you will see there is a binary code, and this is essentially the certain type of code which is written in the Solidity file. Then that compiles down to this certain type of Solidity code. This is the binary code or bytecode. So then let's move ahead. Now we have contract ABI. So the contract ABI means your application binary interface. Let's say we have a bytecode and we have an ABI. Then they both make connections to each other. Then the connection which is built by between them, then it shows the output of the code, and then the machine uses that to show us the certain type of output. This means that that defines a standard schemes to how to call functions in a smart contract and get data back. Methods and structures are used to interact with the binary contract just like an API does with the lower level. And the main function, if you look at this is basically in the JSON format. You can use ABI to make a structure to get the data for your certain type of contract. Let's say now, if you may have heard of contract is basically essentially a certain piece of let's say if I have a contract, everything which is written in a blockchain are termed as a smart contract, and basically this is in a JSON format. It returns at the inputs. We have an input of U into 56, a name. These are the data types which we are just I will touch upon that in later the video. We're going to be covering about how you can install Metamask on your system. So I am using Microsoft Edge today because I already have my wallet installed on my Brave browser. So that's why I am going to be using your Edge. So let me just install it from this. Let's say Brave. So let's start the wallet from the very fresh. First thing first, let's hop onto the website metamask.io. So make sure that you are on the correct website. So make sure that it's .io domain, not any other domain, right? And it should be the name would be good. Let's say metamask.io, and then just press enter and just hop on this website. So once you are on this website, it says that it's a crypto wallet for gateway to blockchain apps. And what essentially the app is it basically a wallet, a crypto wallet that holds your cryptocurrencies. Think of it like your account, like a traditional bank, but this holds your cryptocurrencies, and this works in a decentralized manner. And you can send wallet, you can receive wallet, you can also swap your currencies. Means you can swap from ETH to, let's say, Luna, or let's say any other cryptocurrencies. You can do so from this certain type of wallet as well. Cool. So now let's go to this website and click on this download click on this download. Then we have these three options. If you are on iOS, if you are on Android, you can also download for that. Now click on this install Metamask for Edge. I am on Edge just for testing purposes, that's why I'm going to be using on this. Click on this get and add extension. Then it's going to be adding this extension to your system. Cool, now it's done. So once that's done, you will be bringing up to this screen. Yeah, so once that's done, you need to just click on this extension, and then this is local website, means this is extension. If you look at this extension / colon / then it's basically the initialize app. So once you are on this certain thing, click on get started. Now we have two options. So if you want to start from the really beginning, you click on create a wallet, but you already have a wallet. Let's say you already have a crypto wallet for yourself, then you can import your wallet from here as well. So you need to have your secret recovery phrase. So that's a certain type of phrase which you got when you are making a wallet. So that serves as a private key for your wallet. That essentially, if you have that thing, then it's the control of the wallet is your own hand. If someone other person have your own credential, then they can easily access your account. That's why it's essentially most important thing which you should have. You can secure that thing. Let's say we want to create the account from the very scratch. Let's click on create a wallet. So then it will bring up to this screen. This screen says that they just have their terms and conditions. So click on this I agree. Then you need to add your passwords. So let's say this password is for your local system, right? So let's say add the password for this. I just adding. So once you're done with the adding the password stuff, click on create. Once you click on this create button, then it will bring up to this screen. This screen says that how you can secure a wallet. So just a simple set of video that says you can just watch this video if you have time. So this says that how the functioning of recovery phrase kind of works in the crypto ecosystem, then how you can easily secure that thing, and you can all sort of stuff. Even though you can also add fingerprint if you are on your iOS or maybe like Android, you can do so. But we are right now on our system on a PC, so we can just you can just storing the recovery phrase on a separate secure place, right? You can save it in your zip, maybe in your desktop, or maybe you can secure it to any password management system like 1Password and stuff, right? So you can do so as well. Now click on the next button. Then this is the place. Now over here you will get your secret recovery phrase. So this is essentially, you don't need to disclose it to anyone, right? I am disclosing this right now because I am not gonna add funds to this account, and that's why I'm disclosing it. But if you, in your case, do not disclose it to anyone, right? This is act as a backbone of your wallet, right? If you disclose this to anyone, then they can easily access your account, and then they can easily move on funds from here and then there, right? Now click on this. This is basically your recovery phrase. So just essentially copy this and make sure you save this to your any other places. Let's say you can make a .txt file and then save this in your that file. And yeah, that's basically that. Then click on this next button. Then you need to enter the thing which you have right now. Let's say we have a thing. So once you've done that, just click on confirm, and now you have your wallet set up. Now this is the last step. When you click on all done, it will basically shows your wallet. Now this is your wallet and this is your first account, right? So over here, if you click on this, copy to clipboard, you will see this is your public key. Now click on this, maybe like Etherscan. Etherscan is a place where it's basically a block explorer. Now add your address over here and click on search. You will see this is your brand new account, right? It has 0 Ether, $0 and all sort of stuff, and this is essentially the main account. Now this is your account, and then over here this is your Ethereum mainnet, right? Now if you want to if let's say we are developers, so we want to test our transaction first on the test network, then we can move on to the main network, right? So first thing first, make sure that you enable the test network. So click on this show/hide your test networks, and let's say we have showed this test networks. Click on this, on this up, go back. Okay, so go to home. Now we'll see, we'll show a lot of test networks. We have Rinkeby, we have Coven, we have Robston, we have localhost 854. You can connect this from your local system as well. Let's say you are using hard hat, you can connect from here as well. And this is essentially the main thing, and you can test your networks from here, and then you can easily do all sort of other stuff. Now we want to import tokens. Now this is your main Ethereum mainnet, and Ethereum mainnet consists of a lot of tokens. You can make your tokens on top of Ethereum, right? So let's say we want to import tokens. The search for token, let's say we are using USDT. Import USDT. Click on next, import this up. You will see now this is your USDT, which is built on top of Ethereum. There are a lot of coins, right? Let's say Mana is also a coin. or decentralized land, you can also import it. Like the mana is essentially built on Ethereum, so that's why it's essentially you can import the assets from here as well. Now this activity, this is the assets bar which shows your currency which you hold right now, and then there is a section that is activity. The transaction which I have done so far, it is nothing, so that's why it's showing me nothing, no transaction yet so far. But if you go to my another wallet, let's say my wallet over here, let's say this wallet, and the password, right? Now over here you will see I have some sort of ether in my mainnet, and this is the place that shows your assets, and this is the place that shows your activities. Now this is the activity that may be like you send this amount of ether to some sort of other person, you set a name services, right? You all sort of thing you can see from here, just from a window, right? That's how thing actually works in this activity bar. And then you can also import a lot of other networks as well, right? So let's say we want to import let's say Polygon over here, right? So you can do so as well. Let's say in my case I already imported Polygon. Let's say I already imported Polygon mainnet, so you can see I imported Polygon mainnet, and you can just easily use that as well, right? So that's essentially. And now over here, let's say right now we have Ethereum, that is also a different network, and then Matic is also a different network. So we can say in the Matic as well, we have a lot of Matics available for our balance. Then we have DAI, we have wrapped ETH, we have USDC, we have USDT, right? The other USDC, USDT they're built on POS, and they are essentially built on this Matic network, right? So that's why they are also tokens which are, you can also make your own token on mainnet as well. I will show you in a couple of videos. So that's all from this video. So now you can be understanding how you can write hello world in Solidity. So in the previous video I share with you how you can install Metamask on your browser. So I hope that you watched that video and you can install that browser in your system. So if you don't, just first watch this video and then install in your system. Cool. So now we're going to be getting started and showing you how you can write your first program or hello world in Solidity. So just like any other programming language, Solidity also have its own system, another data types and all kind of stuff. So essentially just like VS Code, we can also write Solidity in a VS Code, but Ethereum itself has an environment or IDE for this Solidity development. So you can just go and search for remix.ethereum.org and press enter. This is essentially an Ethereum IDE, and this is the most simplest IDE, right? You can also write Ethereum code on VS Code, but this IDE or this Ethereum IDE provides us really a very interactive way to write a contract, deploy a contract, and just to test our contract. So first thing first, if you're starting from the really beginning, you will don't see any workspaces over here, you will don't see anything over here. So just go to this website, Ethereum, remix.ethereum.org. Even I can put the link of this website in the description below. So first thing first, this is the look, this is the outlook of the website. So this is essentially an IDE. Now over here, this is essentially the file explorer. Here the code of the contract goes away. .sol stands for Solidity, this extension for your Solidity file. So then we have this search file. You can even search your file from here as well. This is the compiler. You can compile your code from here, and over here now you can deploy your code or essentially your file or your Solidity file to Ethereum virtual machine, or you can also deploy it with injected web3. Cool. So now first thing first, just make a new workspace. So we're going to be making a workspace of Solidity tutorial, right? So just make it this and make that. You can add default theme, you can also add a blank theme. As of now we can be using a blank theme, so let's say Solidity tutorial. Just click on OK. So now we have nothing. this is essentially there's nothing filed in this. So first thing first, make a new folder. Let's make this folder, name this as contract, right? So once you make this contract, just make a new file of hello world.sol, and I can even increase my font if you want. Cool. So over here you will see this is our file which we just make right now. So this is essentially hello world.sol. Now first thing first, I already showed you how you can add your first comment. So every time you make your file, you need to add a comment in the top, that is spdx license identifier. It should be your MIT, or you can also write a license over here, but I just write MIT. Then we need to specify the version of Solidity which we're going to be using. So first thing first, you can add pragma Solidity, and you can add let's say the current version would be, you can add 0.8.7. Now this means essentially that we're using this exact version for our compiler. So which means every time when we run the code, when we run this single file, this would only work on this compiler, right? When we add this sign over here, this means this file would run in the 0.8.1 compiler, 0.8.2 compiler, and any other decimal file, any other decimal after your 8, right? So we can do that as well. And we can also specify another thing. Let's say we can also use let's say this file would run from this, or we can say okay 0.8. Let's say 10, or let's say we can remove this to 1 and make this, let's say 5, right? This means it would run from this file, from the version which are in between this, or the version which are in between this, right? We can also specify our file type in this manner as well, right? So as for now, we're going to be using port 0.8.7, right? And then we are going to be specifying a contract. Let's say we can be using contract, and let's say add hello world. Now if you're familiar with any other object-oriented language like Java or maybe like JavaScript, you will see this contract will work as a class, right? Just like in any other object-oriented language, we have classes, but in Solidity we are specifying contract in the exchange of classes, right? Now the main logic of our app is to come inside this contract or this class, right? So you can think of it like the same as Java or maybe like JavaScript. So yeah, that would be the same. Now we're going to be specifying a string. Now this is a string. Now we can specify, like, say hello equal to hello world, right? Now we also need to add public over here because we want this to be seen in a public case, right? So this means we have this string, this is a data type which is public, and this is named as hello, right? And it is equal to hello world. So let's say we are done writing hello world in Solidity. Now we can go to this section, this Solidity compiler, and now if you look at this, I selected 0.8.7 over here, and if I make this, let's say 0.8.5, it will compile. So let's say it's just adding this, just loading in the compiler. Yeah, so if you click on compile, it will work, right? So this means every time it would work in 0.8.7 as well, and any other version, right? 0.15, 0.14, 0.13, and any other version which is greater than 0.7, right? So we can just again back to 0.8.7 and again compile this. Now you will see this check mark over here. This means that our, I would say, compiler compiled this file successfully. Now over here you will see there's a section of publish to IPFS. There's also a section of Swarm. Swarm is essentially the same as IPFS. It's basically a service for the same. Then we have this bytecode and ABI. So in the previous video I shared with you what's the meaning of bytecode and ABI in Solidity, so you can just check this video. And then there's a section over here that is deploy and run your transaction. Now over here there's an environment section. In this environment section we have JavaScript virtual machine, and we have JavaScript virtual machine of Berlin, we have from London, and we have injected web3 and web3 provider and all kind of stuff. So now this virtual machine means that these are the bunch of computers who are sitting in any other places, and the main purpose of using this virtual machines is that we can easily test the transactions in a various account. Let's say this virtual machine provides us with 10 different accounts, and every account have 100 ETH deposit as their balance, right? And also these would be a fake ETH, it's not real ETH. So these are the fake accounts with have 100 ETH deposit in them, and essentially we can use any of this virtual machine. And over here, as for now, these both are same. This means this virtual machine sitting in London, this means they're sitting in Berlin, and this injected web3 means that we want to inject a web3 into our certain system. So which means injected web3 means if you know, I already installed a web3 browser, web3 I would say wallet, that is Metamask. You can also inject that wallet over here and test the transaction, right? So we don't want to do that because it's a tidiest project. So let's say start with this virtual machine and just use this. Yeah, we also have this gas limit. It's essentially the gas limit which we're going to be using. So this is really high, right? So this by setting up this gas limit, we can easily send a transaction and it's going to be speed up really fast. So yeah, that's we have. And now you can select your contract. So as for now we only have this single contract, so that's why we just selected this single contract. And once we click on deploy, you will see there's a transaction ran through over here. You will see this check mark over here, and after that you will see there's a section over here of recorded transaction, and we have seen a new transaction over here that is submitted over here, that is of hello world. This is a contract name, right? You will see there's a contract name of hello world, and it's the same over here. And you will see there's a et, which means which is who made the transaction. So we'll see the now you will also see that the balance which is before, which is 100 ETH, now it reduces somewhat, right? And this amount of balance, it vanish in the gas limit. So essentially if you look at this, I already added a gas limit over here. So it essentially cut down a certain ETH in our balance, and the balance which is cut down from a wallet goes into the transaction fees for this transaction, right? So here we go. So over here you will see there's a et, means who made this transaction, and this is a balance who made this transaction. And then if you click on this hello, this is a string of public that returns a hello world. We will see that there's a string that says hello world. So just click on this. Cool. So we'll see there's a string that says hello world. So cool. So now we have successfully write hello world in Solidity. Now we'll see you in the next video, in which we'll covering upon what are data types in Solidity. So here we are now understanding what are data types in Solidity. So now first thing first, let's make a new file. Let's say make a file of data types.sol, right? And let's just copy the first two lines because I already explained you what are these lines meant. So this means essentially we are specifying this license identifier from MIT. Then we have this version of Solidity which we are going to be using 0.8 decimal to 7 maybe like 8 or 9 or anything. Now if you're familiar with any of the data types, you will understand. I will try to classify the data types of Solidity in broadly 6 types. So now let's say types of data types in Solidity, right? So now first thing first, first one we have with us is our uint. Then we have our int. Then we're going to be having our string. And then we have our boolean, and then we have our address, then we have our bytes, right? So that's essentially, these are the 6 types in which our data types in Solidity are primarily defined. Now first thing first, let's make a contract. Let's say make a contract of types, right? And let's just start filtering them. So let's say we are going to be using int, and by default uint is specified to uint 256, right? So these are the essentially, so these are taken. So now over here, now this means that this uint, the uint, if we can meant the uint is tend to be an unsigned integer. Let's say unsigned int, right? Which means it can only be a positive integer, right? Means unsigned integer, it's already be a positive integer. Cool. So now this int can be negative, it can be negative, or it can be positive, right? And the string is simply the string which just come inside over here, and the boolean is essentially your true or slash false. Then we have this address. So address is essentially your void address, which I just show you over here. So let me just enter my password and let you know what are essentially address in Solidity. So it's taking some more time. Cool. So if you look at this, this is our wallet address. Let's copy this, and then you can essentially paste it over here. And another thing, these address can't be, so a lot of people make mistake, they tend to fill this address in string. So this is, these aren't, they are, let's say they aren't filled with string, right? So a lot of people tend to allocate, a lot of people tend to take them inside a string, which is not possible, right? So these are essentially independent, so we don't need to essentially fill them in a string, right? Cool. So then we have bytes. So bytes are essentially a collection of bits. So if you understand what are bits, so let's say we can add extra information for you for your information. We can say that 1 byte is essentially equals to 8 bits, right? Now bits are essentially, so if you understand bits are essentially 0 and 1. So 1 byte is essentially a collection of 6 bits, and these are bytes. So now by default bytes are essentially a collection of bits, and which are represented in a dynamic array. So when I say bytes, so we can say a byte can be anything. Let's say we have a name like Ankush, right? We want to convert this into bits, right? So that people, so let the machine able to understand that. That's how the bits are come into the picture, right? So yeah, we have this thing as for now. So let's understand, let's try to do, and yeah, so what we can do now is we can essentially use them in a program. So first thing first, we have to specify that event. Now let's say make it a event, because unsigned integer means it's a positive integer, and we are going to be adding this as let's say my number. Now this is equals to, let's say, 8, right? Then we have a int. Now this int is equals to my int. Let's say we just specify any of the name, and this is the int is equals to -8. We can just specify anything. We are just specifying -4 because we know that the int can be negative or it can be positive. Let's say next thing which we have is a string. Now string is essentially my name. That's like that. Let's say I just put my name, and make sure that you are aware of this semicolon, because if you don't add semicolon it will give you an error. So that's why it's really important to add semicolon at the end of your, let's say, code, or at the end of a line, or at the end of a certain type of execution. The next thing which we are going to be using is we have this boolean. So let's say boolean stands for bool. Let's say is true. Let's put this as true. Let's say false. It's false. Then we have our address. Let's say put that address as owner, and we are specifying our address right over here, and cool. Now next thing which we have is bytes. So bytes are my bytes, and we can just specifying anything. Let's say we are specifying Avengers. Cool. So we have done passing every by using every data types. So we have a uint, we have an int, we have string, we have boolean, we have address, and we have bytes. So we need to add a public over here because we know that we can't able to use this. So let's say I will just show you an error. So let's say errors are also important. Let's say if I don't write public over here, and let's just deploy the contract over here. Let's say deploy, compile. Yeah, so now if you look at this, it's giving an error because I don't write semicolon at the end, right? Let's check. Cool. Let's say go over here and just deploy this. It's selected up this file, deploy, and you will see we show nothing. So if you look at this, there's nothing over here to call, right? That's why I need to specify that it's a public function or public type. Let's say we are using public over here, and we need to add public for almost every type. Let's say add public over here, public over here, public over here, public over here, and public over here. Cool. So now let's again compile the contract, deploy this. Now the deploy version for this contract, just you can delete the previous contract. Now when it deleting this contract from here, it doesn't mean it deleted from the blockchain, right? It just delete from this space. So it's basically stored in the blockchain, right? So it's not permanently deleted from the blockchain. So now again deploy this over here. You will see now you will able to understand these buttons are essentially pop up. So we just click on this is true, it's false because we specified this false. My bytes. Now these bytes are essentially converting this number into these bytes, right? Now we can also add my int. My int is essentially -4 because over here it's -4. Now we have my name. My name is my name. Then we have this my number 8, and then we have our owner, that is our address. So we're specifying right over here. Cool. So now we understand what are data types and Solidity. Now let's in the next video we'll cover upon that how we can essentially use variables in Solidity. Yeah, thank you. And now let's just make a file right over here. Let's say variables.sol, right? So over here we are going to be writing a code. So in the first the top header file, header syntax, just copy from here, paste from here. So what this exactly mean, I already shared with you. What does this mean? This means this essentially a identifier which is which we can identify that we are using MIT license for this project. Now we have this Pegma Solidity compile that this line tend to know the compiler that we're using this version of Solidity. Cool. Now let's understand what exactly are variables. So variables are certain piece of numbers, right, which you can use in a code. Now by default there are three type of variables in Solidity. Now let's just make a multi-line comment, right, and just share with you what are those, right. So there are three types. So types are of three, right. So now the first type which we have is our local variable. Now the second one which we have is a state variable. Then third one is we have is a global variable. Yeah, so we have these three variables, right, and then let's just understand what does these all mean, right. So the local variables are declared inside the function, and these are not stored on blockchain. So let's just write over here, declare inside the function and not stored on the blockchain, right. Now the state variables are essentially basically these are just the opposite of your local variables, right, and these are declared outside the let's say outside the function and stored on the blockchain, right, blockchain or function, right, chain. Yeah, so what does this mean is essentially, and if you may fill in with functions are used inside your contract, right. So that's why we can say that these are the main logic of our app is come inside your contract. Now we have global variables. As the name suggests, these are the global variables that essentially provide the information about the blockchain, right. Let's say add over here, provide information about the blockchain, right. So we have these functions right over here, right. I think I can use tab. Yeah, I can use tab over here. So now we can add a contract over here, and let's just make a contract of variables. Now we can add multiple contracts in a project, right. If you're not familiar with that, we can add multiple contracts in a project, right. This may be like this is a contract A, this is a contract B, and this is a contract C, right. So we can add multiple contracts in a project. Now let's just add the logic of our first way. Just use variable right over here, right. So now let's just do stuff, right. So let's just make a string. Let's just make a string of which is a public, by the way, and this should contain the name of this would be name. So let's just put my name over here, and let's just make a uint public, or let's just say age that like 15, right. Now these are essentially came under the category of your state variables, right. So if you look at over here, these are declared outside the function and stored on the blockchain, right. So you can write over here that these are your state variables, right. So these are your state variables. Now let us understand what are your local variables, right. So let's just make a function. Let's just make a function, or let's just say something, and let's make it public, and we're going to be adding a view over here. I will just let you know what this view means, right. And let's make a uint over here, of x, and this x is equals to, let's say 16 or let's say 18. Now these are essentially known as your local variables, right? Let me just put a comment over here. These are your local variables, right? And if you look at the definition of this, as I already mentioned in the talk, that the local variables are declared inside the function. Look at over here, we declared this inside the function, and these are not stored on blockchain, right? So, which means that these are not stored on blockchain. I will also show you an example. What does this mean, right? And let's just move ahead with your global variables, right? So let's just add a comment over here that these are global variables. Global variables, right? And let's just make a function. Let's just make a uint of let's say time stamp, and this is equals to block, and let's say block dot timestamp. Now these are essentially the default parameters, right? These are the default parameters, or you can say anything, which is provided by the language itself, right? And then we can add an address, and this is a sender. Let's just make it sender, and let's say add a message dot sender, right? So these are came under the categories of global variables, right? Because these are already defined by the language itself, and we can use that over here. Now let's just compile our contract. Just make the font big. Cool. So let's just go over here, compile the contract. It's giving an error. Just I will let you know why this error is tend to came, because we have this unused local variables, we're not using it, right? That's why it's giving us an error. And so yeah, we can also add returns over here. Well, let's just forget that for a bit of a second, right? So it's just a warning. Let's just go over here, just deploy on the virtual machine, just deploy it over here. Cool. So over here we'll get this public which we already have. Let's say we have this age, right? We have this name, we have this or something which we have as function. Now let's click on this age. It will give us 15 because we already have 15 over here, and you will understand it will return uint256, which means now uint itself versus and uint256 both are same, right? Even if I just write to uint256, this would be same, and even I also write this uint256, these both are same, right? So that's why it's giving us the same. Then if we click on this name, it will give us ankush because I already stored ankush as a variable. Now when you click on this something, right, it will show us nothing. Look at this. We click on this, it will show us nothing, right? That's why this error is popping up, and the main reason why you will see this is not working, right? This timestamp and kind of stuff, because we don't provide it's public parameter over here. Let's say you just provide a public over here, and the same repeat the same line word over here, public. Just save that up, and again just delete from here, deploy this. That what is happening over here. Now we have this age which is 15, name the sender. Now sender is essentially the sender which I added over here. Now this sender is essentially coming from the sender who sent this transaction, right? So if you look at this ending with ddc4, and if you look at over here, it's ending with ddc4, right? Which means the address who is the person who is deploying this contract, that address is coming over here, right? So there are a lot of type of these functions in Solidity. We can just use that. We can easily use that over here as well. Now something will return nothing. Then you have this timestamp. The timestamp will return the time, which is right over here. Now this time isn't in the IST or GMT, right? So you can convert that. There are a lot of converters online available. You can convert that from here as well. So yeah, that's essentially everything which we need to understand right over here. Now also if you look at this global variables, right, now I define over here that these provide information about the blockchain, right? Even if you just go to, let's say, let's go to block explorer for your Ethereum. Let's go to etherscan.io. Right, so over here you will see, let's say, just open up any other transaction. Let's click on this, and you will see there's a timestamp prompt over here, right? This is a timestamp, right? And this is the block number, right? So that's how it's going to be providing us information about the blockchain, right, as per the definition. So yeah, so if you look at this, we also have value, we also have from, and we also have this message.sender, means from where the who sent this transaction, right? So you will see the person who's sending this transaction is right over here. That's how everything is working yet so far. Cool. So in the next video we'll look into another thing. Now let's see what are constants in Solidity. Let's just make a file, constants.store, rename, this should be soul, right? So first thing first, let's just get the header file from then. These are actually the same. I already shared with you what are these meant, right? So let's just make let's say contract of constant, right? Now as the name suggests, the constant means the values which aren't changed, right? Let's just add a comment over here, right? Let's say these are the variables which cannot be modified once declared, right? So these are these stuff, and then we can add, let's say, make a string of just make a string, and this string should essentially a public string, so because we want to see it, and let's just make it a name, and just put a constant over here, constant, right? And just add the name of Solidity, course, and let's say add a event, and this event again should be a public function, public keyword of constant, and this should be our subscribers, subs. Now this, let's say we have, I don't know, we have I guess 140 subscribers now. So now, so this constant means that once we declare this name, so we can't change that. And let's say we are compiling this file and just running this over here. Let's just delete from file again, and you will see it just showing us the name and the subscriber count. And just in case, if I copy this thing and just try to paste the same over here, just paste the same over here, and let's just give it a name, let's just give it a number of, let's say, 900, and again compile this, it will give it an error because the identifier already declared and we can't essentially change it, right? That's why it's giving us an error. That's the important of this constant. If you're working on a large file which have multiples of variables, right, so it would be useful in that case. So yeah, that's from this stuff. I will see you in the next video. Now let's look into what are arrays in Solidity. I'll just close these tabs, just make a new file of arrays.sol, right? and just add spdx license ID identifier should be MID. Add a pragma of Solidity that this is a version of 0.7, right? And now let's look into arrays, right? So let's just classify them. Let's just add a multi-line comment and types of arrays in so. Cool. So now the first one is we have is fixed array. So this is simple one. So if you're only familiar with any other language, these are super easy for you, right? So then we have this dynamic arrays. Yeah. So we have these two type of arrays in Solidity as well, and so you can make notes, or even I can share this code for you in the description. So let's just add a contract for us. Let's just do a contract, constant, not the contract of let's say arrays, and what we want for a contract is we want to have a event. Now this event is going to be an array, right? This event is going to be an array, right? And this essentially is going to be a public of array1, right? And let's just make another array of event. This event is another public of array2. Now we can specify that the value for this array. Let's say add a 1, 2 or 3, let's say, and right, so we can specify these values as well, right? Now this one right over here, the R1, is an example of a dynamic array. Dynamic okay, example. Now this is basically the fixed array. This is an example of fixed array. Example, right? Now let's just add another array. You can also add a initialize fixed array. Let's say just try out this one, and add a public of array3, and let's just add this. Now we can specify the limit for this array. Let's say we can add a 10 over here. Means this array can have 10 values, right? Which we can start from 0, 1, 2, 3 and goes all the way to 9. And we can just add over here fixed size array. All the elements are initialized with 0, right? Fixed type array, all the elements start with 0, or we can also say initialize over here, initialize with 0, right? And yeah, so we can also add a function to this for more simplicity. Let's add a function that gets. Now so this is the function of get, and let's just add a public to this of view, and let's add a return, and now this get function will get a event of I, and it's gonna return a event, right? Because we are passing in a event, then it's gonna return it as a event, and then we want to return array1, and this should consist of I, right? So it's a simple function of name getting an event of I, and I will let you know what is this returns and this view meant in the upcoming videos, right? So this is public function, which is a view returns a event, and it can return a event of array1, which is of array, right? And yeah, that's essentially everything. If we just run this program, let's just run this again. Yeah, you will see we can specify, we can add the array. Let's say we can add 1 2, let's say add 2 3 4 5 and all kind of stuff, and then click on this one array call, and you're gonna call the function, and you can add multiple arrays, right? You can even add this array, and this is all kind of stuff. So that essentially everything. I will let you know about these view and returns in the upcoming videos. Till then, bye. So now let's understand what are loops in Solidity. Just make a file of loops.sol, right? And just add your license identifier right over here. License identifier of entity. Let's increase the font so that you can read it properly, right? Let's add a pragma solidity of 0.8, and put this 7 right over here. And now let's see that how many types of loops are there, right? Just add a multi-line comment so that I can write and explain in more brief manner, right? Let's say types of loops in Solidity. Now the first type of loop which we have is for loop, and second one which we have is your while loop. The third one is we have do while. Now this might, if you are familiar with JavaScript or like any other language, these are essentially the same loops or even same concept used in that language as well, wherein we most probably use this for loop. We don't use this while loop or do while in most of the cases, right? Let's say you can add a comment if you want that while loop and do while do is rarely used, right? So now let's hop on to the main concept. Let's just make a contract over here of, let's say, loop, and let's add a function to this function of loop. This function, it's going to be a public function, which is a pure function. Now if you're not familiar with this pure concept, I will make a video on explaining the view, returns, everything in the upcoming classes. Just stay tuned for that. Now we can add let's say we can add a for loop right over here. I'm just showing an example for for loop. Let's say now every time when you write a for loop, you have to add for this keyword right over here, and let's take a event, and which is a event, and now that this event, let's say we can make this event as 0 at the initial case, and then if the I is greater than 0, let's say we can add a when it's greater than 0, when it's smaller than 0, we're gonna increment I plus plus, right? Or we can even say I is equals to I plus plus 1, so that will be the same. So you can even add I plus plus, so that essentially the same concept or the same thing which we are going to be using, right? So now when so initially we have this I, which is a event, which means it's an unsigned integer, which means it's a positive integer. If that I is less than 10, then we're going to increment that by 1. yeah, and then if it doesn't, we can also add a if statement right over here, which means if the, let's say I is strictly equal to 3, we're gonna continue this thing on the we're gonna continue, else we're gonna let's say if we have I check to 5, we're gonna break, right? So this is a simple concept of how you can use loops in your this. Now this means that if when the loop is equal to 3, then we're gonna continue. If it is equal to 5, we're gonna break, right? That's how you're gonna be simple. And yeah, let's say take an example of while loop over here. A while loop, this is very rarely used. I often not use it very much. Let's say we're gonna be using while loop, and let's just make a uint of uint of 56, or let's say uint simple one, and this would be an example of j. And let's say while we have j is let's say less than 10, right? We're gonna increment, let's say j plus plus. Cool. So now this we have a simple example of while loop, how we can use it. Let's just run this program and let's see what eventually happened. Okay, so it's showing us that we need to have a function or struct. Okay, so I need to pass this inside this function, so that's why it's causing the error. Again, compile. Cool. So let's just deploy this. Deploy. So we have this loop. Click on this loop. It will show nothing because now we aren't printing that on the console or on the screen itself. Right, so that's how a simple loop can be formed, right? It's a simple example we can use in our contract if you want. So yeah, that's essentially everything, and just wait for this update of what is pure and this public, everything in the contract. We'll let you know what are these. So now let's understand what are constructors in Solidity. The first thing first, constructors are also present in other languages like Java and C, and these are essentially your optional functions which are executed only once, right? So let's say if I just take an example, let's make a constructor of, let's say, uint of, so let's say make it public so that we can view it. Let's say take in my name, or not just take my name, let's say value, right? So we have a uint which is a public and which name is value. Now let's make a constructor. Let's say make a constructor. This constructor is essentially like a function, right? But these are essentially an optional functions. Let's say if I have a function right over here, let's say main, right? So this syntax looks a bit like same, right? So these are tend to be an optional functions, and let's say if I it can take arguments. Let's say if I pass in arguments, let's say mine as uint of let's say value, right? So now let's say we have a uint, so I pass an argument of underscore value, and let's say make this value equals to underscore value. Cool. Now just run the script. Okay, so it's facing an error. Save this up, compile. It's compiled again. Let's say just deploy this up. Now while deploying, there's a section that says this is a value, right? So now say every time when you have a constructor, you need to first specify let's say we have this constructor right over here that's like an argument of value. So we provide a value of uint, let's say 90. Click on transact. The transaction went through. It shows as value. Now this value is equals to this constructor. Now this is 10 to be equals to this value. Now this is also equals to your 90. Cool. So that's how a constructors kind of used to works. And yeah, it can take multiple arguments. Let's say we have a uint of this. Let's say we can also pass a string of let's say we have a string of name. It can take a string of, let's say, bool your age, something like that, right? So you can pass multiple arguments in this constructor, and yeah, that essentially everything. And also I also want to share a quick example with you of another constructor. Let's say I just take that constructor right over here. So let's say let's just comment this constructor right over here. Let's just make another constructor of, let's say, address of owner, right? And let's say my constructor of constructor, and this constructor should take this doesn't take any argument. Let's say make an owner is equals to message dot sender. So this is essentially a global variable, and if I essentially, so let's make it public so that we can able to view it, and just save this up, throw this up, this transact, and you will see the owner, it's essentially the owner who deploy the contract, which is we in our case. Now someone may ask that we can also specify, let's say, instead of writing this constructor right over here, we can also says the owner is equals to message dot sender. Is that we can add in the function? Is that we can add right over here message dot sender? I says no, we can't add that, because these global if you may have heard of this global variables, these only be these functions or these global variables can only be accessible inside a function, right? So instead of making a function back and back again, we can make a constructor. Let's we can make a constructor, and then we can add a owner that says mess.sender, right? So we can do that as well. Or even if in case if you can do, let's say, even I can provide my own address. Let's say we have this address right over here, right? So let's say just copy this address, and let's say we can add this address right over here. We can do that, but if you are working on a large project, you do need to do this back and back again. Or even if in case someone duplicate your contract, they may not, it's not a good thing, right? So that's why if you are writing such a complex contract, don't just add your own. Let's say this is your own address. Let's say if this is your own address, try not to add the same address right over here. It's not a best practice to use that. You can do that. You can do that if you want, but this isn't a good practice if you are working on a good project or in a big project, right? So always use constructor in that case. Yeah, that's all. I will see you in the next video. Let's see what are immutables in Solidity. Now immutables are essentially the variables like constants. Let's say if you watch the video of constant which I just made before, the constants are a piece of keyword which can be written in your contract, and these can't be changeable afterward, right? So if you change that afterward, it may throw an error on the console or maybe in this bar right over here, right? So let's just understand that what's the main need of the immutable, right? So immutables are, the main need of the immutables are essentially the gas cost for immutable variables are much lower than the state variables, right? And also these are also usable if you had more kind of complex contract, right, wherein a lot of other contract, let's say if you build a contract that had most security vulnerabilities contract, so you can use immutables to solve that issues. And yeah, let's move on, just explain you with an example. Let's say let's just make an address, and this address is essentially a public because we want to view this afterward, right? So we have this public, yeah, we have this public, and let's just pass a immutable. So immutable, okay, I just misspelled the name, immutable, right? We just add immutable right over here, and just add a variable, let's say store this address in this name of address, right? And then pass another event, and this event is essentially a public, and again add a immutable, and let's say add this as my number, right? So we have this thing with us, right? Now let's just pass a constructor, right? Let's say constructor, this constructor we already know it's an optional function. Now this constructor should take an argument. Let's say we had a event right over here. This event is, let's say we can pass my let's say my number, right? Then we can add my address is equals to message dot sender, right? And then we can also say my number, let's say my number is equals to your underscore my number, right? So this is a simple example of how you can use immutable, and also it cannot we can set these immutable inside the constructor, and we cannot modify that. We cannot modify these after once we deploy that, right? So that's how we can use them. Let's just compile this immutable.sol right over here. Just delete this transaction history, and look at this. Now over here it states that my what's your number. Let's say I just put my number would be, let's say 67, and click on this transact, and once we click on this transact, it will basically shows us a public, which is essentially a my address. If we click on this my address, it will show message.sender, which essentially going to be our main address from where we are going to deploy our contract, and this my number is the 67, right? So this will essentially call the same number once we transact that. Click on this transact, it will record a transaction history right over here. Expand this. Now over here you will see this is my address, and if we click on this, we will see that it shows us the address of this from where we deploy the contract. Let's say click on this my address, it shows the same, which is starting from 0x your 5b3 and ending with ddc4, same. And then let's just click on this my number. This my number is equal to 67 because we already deploy and we already allocated the same number over here, which is 67. So that's how we can use immutable in this language. I will see you in the next video. Now let's see what is mapping. So mapping is essentially a data structure where we have a key and we have a value. Let's say we have a key and a value, right? So we can also write in this manner. Let's say mapping. We can specify that we have a key and then we have our value, right? So what this means is that we can easily, let's say we take an example of a college university, and let's say in a college university we have a certain piece of ID assigned to a certain student, right? And through that ID a college board can easily access their name, their roll number, their date of birth, and all kind of stuff, right? You can take that example and just put it down in the code, right? So that's the main that's the main essentially usage of mapping. And also if you're familiar with let's say another languages, let's say JavaScript or Java. In JavaScript it's very similar to object, and in Java if you're familiar with Java, it's very similar to hash map, right? And yeah, let's just start coding. So let's say what we can do. So let's just make a mapping, and let's say we have a mapping, and we can let's say what we can do. We can say that let's make a contract which can get gender from, let's say, address, right? So let's do that. This is we're going to be coding this statement using mapping. So let's say we have a map, right? So this map takes an address as a key type, and then map that to a value, right? So not to use value right over here, because we it's just for a reference, but this key can be maybe like you can add key. This key can be address, it can be bytes, it can be event, anything, right? And we are mapping this address from key to, let's say we are mapping this to, let's say, string, because we're going to be getting gender, right? So gender is essentially going to be a string, right? So we want to get users gender from their address, right? So we're gonna use address, and then we're gonna use address as a key and value as the string, because we can get gender is going to be a string. Cool. So this essentially is going to be public, because we want to see that. And then we're going to be using get, let's say, gender, right? So we have this thing now. So what that does, this thing I already specified that while typing this thing. Now we can also add a comment if you want to make it more clear. So we can able to access someone's let's say gender from, let's say, their address, from their address. Cool. So, or it can be anything. Let's say we can also let's say we have this get, so it's again a comment. Let's say we have this get gender, and as I said that this is going to be a string, it's going to be an address. So let's say we have an address of 0x something, and this entire array can able to access the string, right? I hope that this make more sense to you. And yeah, let's move forward, right? So now we have specified a mapping right over here, and then we are gonna make, let's say, make a function of get user, let's say, gender, and and this gender essentially take an address of user, because we can passing the user, and it's going to be a public, because we're going to see that we're going to view and returns, and you can return a string of in memory. And yeah, so I will let you know what is this view, memory, and all kind of stuff in the upcoming videos, right? So let me just move the font bit. Yeah, so now we have this function of get users gender, which is going to take in parameter of address of users, which is public, which is essentially going to be view returns a memory of string. Cool. And we're going to return let's say return we can return the get gender, right? And this gender should take the users, because as I pass this address as the user, so you can get these users. Cool. So let's move forward and let's say make so if you want to set the gender, let's say if you want to set the gender, we can also do that. Let's make a function for that. Let's make a function to set user, let's say gender, and this gender is going to be a string of memory, and it's going to be set the, let's say we're going to set their let's say what kind of set user gender, right? So we're gonna set that, and now what we can do, and again this should be a public because we're gonna view this, and then we're gonna get this get user, get gender, and this get gender is gonna send the message dot, let's say message dot sender is equals to this user gender, right? User gender. Cool. So we can set that, and I hope that makes sense that what I'm trying to do right over here. By this function we can easily get the user gender, right, from the array of addresses, and from here we can set their gender, right? This memory means we are going to be setting their addresses, so that's why we use this keyword of memory. I will let you know whether this local storage kind of stuff works, storage works in this Solidity language in the upcoming videos, right? This is essentially a public function, and then you have this gender, get gender, which is essentially going to take a message dot sender and then use this user gender. Save this, compile this. Now let's see if I have funds in my wallet, right? So let's say, yeah, I have a lot of funds. Let's say use environment for injected web3. So yeah, so I injected my web3 right over here. You'll see it's connected to my first wallet. This is essentially my first wallet right over here, which have a couple of Rinkyby ETH, right? So let's just deploy this, and let's say we can specify that my current address, it's gonna be this which I deployed right over here. Just copy my address, just copy my address, right? Again just deploy this. We'll open up this pop-up, right, and just confirm the transaction. So once that confirm, you will see there's a deploy contract section will pop up. Yeah, now it's completed. You will see this is our main, so we can set the gender, get the gender, and we can also essentially get the user gender. Let's say we're going to be using this function of, let's say, user gender. Let's say we're going to be using I'm a male, and yeah, we can transact. It will again open up and just ask you to sign and pay the gas fee. Confirm. Yeah, so now it shows us that this is my gender. So now my first gender, it's set to male, right? It's set to male. Now this, yeah, this is a get gender. Now we need to specify let's say if I just specify my address right over here and call this, it shows us that it's a male because I already said that, right? And it's also the same. You can also get the user by their address. Let's say this call, it shows as male. Cool. So now this address has a gender of male, Cool. So now let's use a different address. Let's say we can be using a different address in my account 2. Let's say we have this account 2, connect, right? Now it's connected to my second account, and let's just delete this right from here and click on this deploy. We will open up this pop-up to pay the gas fee, confirm, and we can say second address. So yeah, now it's confirmed, and just copy this address so we can use that. Okay, copy this. Let's say, so now if you click on this, we'll see this is a use iterative. So this is a your, okay, so on this. Yeah. So we have this user gender. Let's say we're gonna be making this as a female. Transact. So now you need to pay a gas to set your gender, confirm. So once that confirmed, now it's confirmed, and now you can essentially get the gender by the certain address. Let's say I just specify this address, call, it shows female. Cool. So I'll see you in the next video. Whenever you run a transaction and whenever you deploy a contract, you will see there is a section of Ether, right? And there is also a section of Gwei and Finny and Ether, right? So let's just try to understand what are they. Now, just like in any other system, let's take an example of India. In India, we have in which 1 rupee is equals to 100 paise, right? And the same for US dollar. 1 US dollar is equals to 100 cents. Just the same in that case. In Ethereum, your 1 ether, let's say for Ethereum, we used ether as its currency, right? So now what does the use of this ether? Now ether is used in several purposes, right? So whenever you send a transaction, right, it also used to pay, let's say it used to pay the transaction fee, right? So whenever you make a transaction, the fee is paid by in the terms of ether, right? Now ether is also have its lot of categories. I make a list of these things. Now we have, Gwei is the smallest one, then we have gigawei, then we have this mwei, then we have kilowei, then we have the mwei, and then we have gigawei, microwei, microether, milliether, which is also known as finny, and then we have ether. Now you will also need to understand your 1 ether is close to around 10 to the power 18, let's say 18 Gwei, right? So this means now 1 ether is equals to 10 to the power 18 Gwei. That is huge. Means this one is the smallest unit and the ether is the largest unit, right? And if you look at the section of this deployed and transaction, you will see there's a section of value, then we have Gwei, then we have gigawei, finny, and ether, the same as these things, right? Now let's make a contract and just see how we can implement that, right? So let's just make a contract right over here. Let's say make a contract of ether, and let's say Gwei, right? Now we're gonna be using a event over here, right, which is which is unsigned integer, which is going to be a public function, public keyword right over here, and let's say we can be using 1 Gwei, right? Now 1 Gwei, we can write over here, let 1 Gwei, right? We can write in this manner also, and we can also write a comment right over here that one way is equals to 1 right over here, right? So one way is equals to one way in this manner. Now we can also make a boolean. We can use bool for boolean. This is a public and it's going to be is one way. Let's say we're going to be trying this up. Let's say one way is equal to 1. It's going to be using that right over here, right? Then we're going to be using another function. We're going to be using another uint right over here. It's going to be a public of 1 ether, and this 1 ether is going to be 1 ether, right? And this means that 1 ether, which we're writing right over here, is equals to 10 to the power 18 10 to the power 18 way, right? So let's say make a boolean right over here again. It's going to be a public function, public keyword right over here is one way. Let's say it's 1 ether. It's going to be checking this thing, ether is equals to 1, right? So we are not going to be using 1, we are going to be using 1 e and 1 8, right? So this means is that the e stand for the e notation. So this means that it's equals to a huge number. So e notation, yeah. So if you look at this, e notation is essentially a way of expressing numbers if they are too large, right? So that's why we're going to be using 10e to the 18, right? This means if you look at this, if you just copy this and let's say just this meaning, now this means 1 to the power 10 to the power 18, right? As we already specified that this means 10 to the power 18, right? Which is equals to 10 1 and then 18 0, right? That's huge, right? So that's all. Now if we just run the contract, compile the contract and then deploy the contract, you will see it's deploy the contract, and over here we got this is 1 ETH, which is this function. Now if 1 ether, as I already specified that 1 ether is equals to 10 to the power 18 and this notation means the same, it will return true. Click on this, yeah, it's true. Now if now this is one way, this one, because one way is equals to 1 as I already mentioned. So if we click on this is one way is equals to true as well, right? So that's how you can use ether and way in your contract. Even if I just click on this 1 ETH, which I already specify, it is equals to this humongous number. Now this equals to now this zeros are going to be 18 0. So if we just search for 10 to the power 18, it will return us to 18 0, right? That's what the same. Now this 1 way is equals to 1 because I already specified that this 1 way is equals to 1. Yeah, that's all for this video. So what is gas price and gas limit? So I just prepared a beautiful slide for you so that you understand this thing in a more brief manner. So let's say that you own this car, right, and this stays at this point A and you want to go from this point A to point B, right? And as for now you have these two most important thing which you want to, if you want to go from this point A to point B, you need to have fuel, and you also need to also understand that what is the fuel price of the point of time, right? So let's say if I have my car which has fuel, which has enough fuel to go from point A to point B, it can easily complete the transaction or easily go from point A to point B. But in just case if you don't have enough fuel, or let's say enough price of fuel in your car, you aren't able to go to this destination, right? You may stuck at this point and then you have to return back to a point because you don't have any gas station right over here. The only gas station in this area located in this destination point A, right? That's why you need to just return back to this A point, and then you need to fill up your gas, fill up your, let's say, car to a certain gas of in a certain limit, like so that you can easily complete your route and you can easily complete transaction, right? So that's the main basic example. Now let's again move forward to understand it in a more deeper sense. Let's say we have this wallet, which is let's say this is a Metamask wallet, and you just sign a transaction. Signing a transaction means if you want to complete transaction, you need to first send that, and then you need to sign the transaction. Now the signing transaction works in that sense. Let's say if you want to sign a transaction, it essentially takes your private key and verify that you are the only person who essentially signed the transaction, right? That's how the signing works. Now let's say just forget about this DD over shield and this MEW node and this Infora and this Etherscan. Let's say you just sign a transaction, then this signing transaction goes to this nodes, and this nodes then goes to this tunnel, and this goes to this tunnel, and go. Then these transactions fill up to this pool, right? Now these pools are essentially the pool of all unsigned, or maybe like all signed transaction. Those are pending right now, right? So the person who essentially pick up the transaction from here and add to the block, those persons are known as miners, right? So miners are those persons who essentially give us the computational power and help in the completion of the transaction, right? So let's say there's a miner A who just pick up a transaction and just add to this block, right? Now once it add to the blockchain, the transaction is permanent. And there's a main thing, the miner pick up the transaction first, those pay a higher gas limit, right? So even if in this case, if you just open up your Metamask, and let's say if you just open up your Metamask, and if you want to send some sort of ETH to your main account, let's say I just copy my second account, I want to send Immutable Ether from this to this. Let's say I just want to send 0.002 ETH, Immutable ETH. Let's click on this next, and over here you will see there's a section of edit, right? This shows us the gas fee, and over here there's a section of edit. Now click on this edit right over here. Now you will see there's a section of gas limit, right? And this thing is constantly changing, right? So if you click on this show recommendation, now you will see there's a section of low, medium and high, right? This says it's likely to be confirmed in 30 seconds with this gas limit. And even if it just if you just select this low right over here, it shows us it's maybe take more than 30 seconds, right? If in case if I just click on this high, select this high one, this says it's very likely to complete in less than 15 seconds, right? That's how a gas limit kind of used to works. If you set the gas limit to a very high section, maybe like in the very high zone, it completes really fast, right? It pick up the miner really fast, and then they easily add to the block, and then your transaction has been completed, right? So that's how essentially the gas limit thing works right over here, right? And even if you click on, even if you see right over here, that states that this is gas price. This is the Etherscan essentially a block explorer where you can easily find all the transactions. All the transactions are essentially coded on this piece of website, right? This is essentially the block explorer. You can easily explore any address, any transaction hash, anything right from here, right? So over here you will see there's a section of gas price. Now this gas price shows us the price offered to the miner to purchase the amount of gas, right? This is the gas which is offered to the miner to complete the transaction, right? That's how it's kind of works. And if you look at this, is the transaction fees. Now this fees is essentially the fees which is taken by the person who is completing the transactions, and this fees is essentially then if you look at this says that max fees per gas times gas used, right? That's how the transaction fee has been recorded or has been calculated. Now let's understand both of them one by one in more definition manner. Let's say we have gas limit, then we have our gas price, right? So let's say the gas limit is essentially the maximum amount of gas that you are willing to pay to run a transaction. Let's say max gas you are willing to pay to, let's say, complete a transaction. Cool. So now the gas price is essentially the amount you want to pay per unit gas as a fee to the miner. Let's say now I already showed you what the gas price means in the right over here, gas price right over here. Now look at this, it says that the price offered to the miner to purchase this amount of gas, right? This amount is basically offered to the miner, who essentially allocate this transaction to the block, right? That's how this amount of money, this amount of ETH has been credited to the miners, right? So we can say that the amount you want to, let's say, pay per unit of gas as a fee to the miner, right? So that's what both of these terms means. I will see you in the next video. Now let's understand what are enums. Now enums are short form for enumerators and enumerables, and enums are essentially used to provide names for integer constants, which makes the contract better for maintenance and readability. And enums they can be declared outside a contract. Let's say we have this contract right over here, we can declare it over here by using this word keyword known as enum. Let's say we had a enum for book, and we can just assign that for book is available, and we can use that, right? We can assign the enumerables outside a function or outside a contract or even inside a contract, right? We can do in both manner. Cool. So now by using enums, they can be useful in reducing the, if we have a limited amount of set, a limited amount of data for your code, right? And hence by using enumerables or enumerators, they help in reducing the bugs in our code, right? So now let's move ahead and understand it with an example. Let's say make an enumerable of user. Let's say we are going to be having this contract right over here, and let's say make a enum for user, right? And this user is going to be allowed, and maybe is going to be adding a not allowed right over allowed. Then we have, when we are adding a wait listed, right? So this enumerable of user is set to be allowed, not allowed, and waitlist, right? So now let's print that up. Let's say we're going to be adding a user, right? User is going to be a public function, public keyword, user status. User status is equals to user dot allowed. Now what this means is, you can think of it this entire enum user as an object, right? Now what this means, essentially we are accessing this index value. Let's say we are accessing this allow by using allow dot user dot allowed. We can also access user dot not allowed and user dot waitlisted, right? And by do that, just think about yourself, what you're going to be seeing as an output. We just compile that up, compile and show the output. You will see the index value for this thing, right? So right now the allowed is set to be at the 0. So right now every time in the index value, they every time start with 0, then it's move ahead to 1, 2, 3 and so on and so forth, right? So if I set this enumerable or enumerable to user.allowed, we will give, if we deploy the contract, and we will see this user status is going to be 0, right? It is 0 because we are accessing this index which is at 0, which is at 0 present, 0 value. Now we are also, let's say if I just add waitlist and again deploy the contract. Now first thing we need to compile that, and then we need to deploy that contract. Deploy. We will see now it's set to 2 because it is this going to be a 0, so this is essentially is going to be a 0 value, this is going to be a 1 value, and this is essentially going to be a 2 value, right, at the 2 index. Now this is going to be show us 2, right? It's going to be 2, right? So that's how we can use enumerable in our code. Now let's move ahead and understand, and let's just make a simple contract to make it more, to understand it more in more brief manner, right? So let's say make a event, let's say make a event of let's say public, a public of owner, and this owner, not add owner because we are using this score right over here. Let's make it 100, right? So now what we're going to be using is we making a function. This function is essentially going to be an owner function, right? And we are setting this function as public because we are going to be using this, and we want to see the function, right? So yeah, we have this public function. Now let's add some if statements. Let's say the user status is equals to user dot waitlist, or let's say allowed. Then what we're going to be doing is essentially we are going to be setting the score as 0, right? So yeah, so if the user status is set to user.allowed, which means if this status now the status is set to, now if you look at this, it's set to 2, right? Now this saying that if the user status is set to user.allowed, which is essentially equals to 2 equals to 1, then it will set the 0 back to 1, right? But it is not equal to that, so it means the score is going to be equal to 100 itself, right? Again, just compile the contract, deploy this, we will see the score thing at 200 because it is equals to 1 and it is equals to 2. That's why this score is unable to set right over here, right? After deploying the contract, if we check the score, it's showing us 100 because it's setting a default value of score. After running this owner function, it's check if the user status is equals to user.allowed, and if it is equal to that, then it turn back to score is equal to 100. Score went back it to 0. Right now user.status is set to user.waitlist, hence this allocating function would not work. So if we just check the score, it stays as it is. If I change the user.waitlist to user.allowed and then compile the contract and again deploy this and check the score function, it's showing me 100, and when I call the owner function and then check the score, it's showing me 0, which means now the user.allowed is equals to user.allowed status, hence the score went back to 0. So now let's move ahead and talk about what are structs. Now structs are essentially a collection of variables that can be of different types under a single name. And now if you think about what are the usefulness of structs came to the picture. Now structs are helpful in grouping together related information, or maybe like if you have a large data and you want to group them together, that's where the structs came to the picture. Now we can initialize struct in the contract, or maybe in the outside the contract. Let's say I use a struct, so let's say I add used for collection of data. Let's say I just make a struct for countries, right? So now the struct consists of a string, let's say name, then we have a uint of let's say ratio, then we have a uint of population, right? So this is essentially a struct that consists of the, now if you look at this, this is essentially grouping together the related information about this certain topic. Let's say we are countries should have a name, ratio, population, etc. In another case, if you want to make a struct for books, let's say book, name, author, and let's say the pages, etc. right? You can make that struct for that topic as well, and that's the basic concept of how you can do struct. Now you can also use struct, let's say if we have this folder structure right over here, and we have multiple files, right? And we want to link two files, one file or two file structs into a single file. So we can do so, just make a new file of structs2.sol, and then you can use import command at the top above the contract. Let's say you can be using import, and this you can import the your structs2.sol, and then you can easily use that right over here. Cool. So now let's take a look into what we can do with structs, right? So let's say we are going to be making a example. Let's look an example of structs. Let's say just comment that I just making a comment for this thing, right? Or just uncomment, so you can be using that afterward. Cool. Now let's make a struct for books. So let's make an example of books struct, so by which we can easily get the book name. We can also and set, then we can also get the book name, and we can also set the book name. So cool. Now let's move ahead and make our struct. Cool. So now let's move ahead and make our struct. Now this struct should be consist of name of book. Now let's say in the book struct we have a string of name, then we have a uint of id. We also have a string of writer. We also have a boolean of available, or you can be using that as well, right? So we have the simple struct, right? And then we are declaring this struct as an object. Let's say we can use that by writing simply book struct, we can be a public, and let's say book 1, right? So we are declaring this entire struct because this is essentially an object, right? And we are making this entire struct as a public of book 1. Cool. So we can also remove that if you want, it will work fine, but I just added that for your information. Now let's move ahead and let's assign some sort of variables. So let's say add a book of book 2, that should consist of book. So we're going to be adding a book in the specific content. Let's say first we need to add this book struct for first we need to add name, then we need to add a comma, then we need to add ID, then we need to add writer, then we need to available. Cool. So let's say the book name which we are going to be adding is ETH starter, let's say, right? Add a comma, then add the writer, because then add an ID. So let's say we can add an ID of let's say 10 right over here, then add a writer. So let's say add a writer of Bob, and then we need to add the availability. So it's going to be a boolean. So let's say it's true. Now it's available. Yeah, so now it's available. Cool. So now we added the assignment for the book too. So now what we have done, so we just added this this book, or this public, let's say add this public, right? So this book, we just essentially added the values for this book in this manner, right? And then let's essentially set the fields. So let's say add a function for, let's say, setting the book name, right? Let's say set book details, right? So it's going to be a public, and it's going to be a public function. And let's add a book one is equals to the same thing. Let's say we can add in this manner book, let's say, okay, let's say Bitcoin for beginners, right? Then we need to add the ID. So ID is going to be 12, writer is going to be Satoshi Nakamoto. Then we add the availability, so it's going to be a false, right? So we just set it the name for this book. So first thing first, I just declared right over here. Then essentially we set the book one as this one, and let's make another function to getting the details, right? So let's say for getting the details, right? So let's say add a function of get underscore details, and now this thing it's gonna be a public function which is view returns, and I will pass a parameter right over here. This parameter is essentially, or we can even add parameter right over here, because it's going to be returns, we're going to be returning from here. So it's going to be a string of memory, let's say memory, and it's going to be a uint, right? So now return the book one dot name, and add right over here book one dot ID, right? So here we go. So right over here we get the book one dot name, and then we are also getting book one dot ID, right? That's amazing. We can now save a contract. Now it's giving us an error, right? Now the error is because of, I think there is some sort of error. Okay, so now it's worked fine. So maybe there's some sort of error for adding the this arrow or this object kind of stuff. So it's worked fine, right? So yeah, now let's deploy this. So compile, it's already compiled. Now let's go over here, deploy, Now the contract has been deployed. Expand this. Now when I click on the set book details, it's gonna set the book 1 details as this thing. Click on this. Now it set the details, but we aren't able to see that, right? So if I just click on this get details, now it's gonna give us the details for the book 1. So now if you look at this, it says that Bitcoin for beginners, and now this is essentially the index, right? Or we can say, now every time when you run the program, it's going to start from the 0 index. Now it goes all the way to 1, 2, 3 and all chronological order. So it's beginning, it starts from 0, and it's beginning from, and then it's going from 1, 2, 3 and so on and so forth, right? So it's a uint because we are returning the UID, so it's going to be a uint, and it's of 12, right? So already specified it's going to be a 12, right? So that's how we can get the function, get the details from our book. I hope that you find this interesting. Cool. I will see you in the next video. If you are familiar with the concept of memory or storage in any of the languages, they are most likely the same, right? So we can say to storing the value in Solidity, we use these 3 types of keywords, I would say, right? So the first one which we have is your memory, and the second one which we often use is your storage, and third one is your call data, right? So we have these 3 kind of storing values, storing keywords which you often use in Solidity. Now let's touch upon both 3 of them one by one. Now let's see what is memory. Now if you look at memory, you can find it similar. Let's compare this memory as RAM, right? Let's compare it with RAM. Now RAM stands for your random access memory, right? So the RAM essentially not stored your entire information. Essentially, if you look at the RAM can maximum can go to 16 GB or maybe like 32 GB, right? And the main function of RAM is to essentially not store the information for the long term, right? Let's say in your computer, if you look at the RAM, the main use case of RAM is essentially when you are surfing any web, right? Whenever you are with multiple programs, if you have multiple programs running up in your computer, right? And you want to switch in between both of them, right? So these switch from one program to another program, it's done in a matter of seconds, right? And these storing values came from your essentially RAM, right? So you have to think of it in this way. Now the storage, we think of storage as a hard disk, right? We think of it as a hard disk wherein they have a high capacity for storage, but the retrieving power, let's say if you want to retrieve information from the hard disk, that thing is very low, right? A huge capacity, you will find your hard disk to maybe like 10 TB or maybe like 1 to 2 TB of data, right? So they can hold that amount of data, but high capacity for storage, but less but have essentially we can say high capacity for storage and but less what can I use right over here, but less power of retrieving the information, right? So yeah, we can use that. And the call data, essentially you can think of a call data as let's say, so this call data is really used, and these are like immutables, right? So once we allocate some sort of data in the call data by using call data keyword, we can't essentially change that. But if we declare that in the memory, we can change that afterward, right? So that's why if you compare now, these storage essentially stored. Now I will share you more, so like we can just add the like immutable dash and the constants, right? And we can't change that once we declare that. Now let's touch upon these things in a more brief manner. Let's say first let's forget about call data for a bit of seconds. I will let you know what about this, and this thing is really used, so we just don't look at this for a bit of second. Now let's talk about more your memory and storage, because you will see every time you will be using memory in your code base, right? So that's why you have to understand the memory and storage first. Now let's add a multi-line comment, so I can essentially use more space, right? So now first thing first, let's try to understand what is storage, right? Storage, and then we have your memory. Cool. So the first thing first which the storage does is essentially it holds your state variables, right? So yeah, they hold your state variables. And the second thing which it does is it essentially stores the information on the blockchain as a permanent, right? So we can't change that. So let's say store on blockchain, right? So we can't change that. Now look at the memory. So memory, essentially we can say memory it does the same. It essentially holds your local variables. So if you're not familiar with the state variables and local variables or global variables, I already make a video in the series, so you will just check that video out. I will put the video link in the description, or you can just check out my channel. Cool. So now the first thing, it essentially holds your local variables, and essentially now if you're holding your local variables, that would be most probably defined inside the function. Let's say, so we know that essentially they can be defined inside function, right? Defined inside the function. And now as we know that storage is permanent, but the memory is not a permanent. So essentially it says it's non-permanent, right? So it essentially stored the I would say code in the memory, right? So that's how it kind of works. And essentially if you're storing the information, if you're essentially storing the information on the blockchain, they are essentially more expensive, because you're now making connection direct to the blockchain, right? So you need to pay more gas, let's say I can add pay more gas, and more expensive, I'd say expensive, right? And now you're not storing it on the blockchain, hence your memory is it's going to be less expensive for the gas fee, right? For gas, right? So these are the broader aspect of what's differentiate between your storage and memory. Now we can also, now as I already mentioned, that you can think of it as a RAM, and you can think of it as a storage, or maybe like as a hard disk. Cool. So let's make a function and test that which function will take which keyword will take more gas. Let's say make a function for memory, and it's gonna be public, and then what we want is need to pass some sort of parameters, right? So let's say add a parameters of string of name, let's say, and they should be allocated in the memory, and then we can be passing a uint. It's gonna be as array memory, and let's say array Let's see address. Let's say add adding something. Instead of adding, let's say add a keyword for age, right? So we have this memory that takes in string of in the memory of name and unit of this. Now let's copy this and see the same for call data. Call data should use this instead of memory, they will use call a data, right? So just compile this, and I will not using storage right over here because we need to use storage outside of your function. So I will just let you know why I not specify another function with storage keyword right over here. If in case if I do that, it will throw an error. Let's say if I essentially use storage and just make this function as storage, and let me just essentially change these because maybe like we need to have them. Username, age, old. Let's add a name one, and let's say wait. Okay, right. Now if we compile this, now it essentially give us an error because of this thing, because I already shared with you that why you don't need to add storage right over here. If you look at the error, it says that data allocation must be a memory or call data for the parameters in the function, right? Yeah, that's why it's giving us an error. We don't need to specify storage inside of a function, right? So that's why I will let you know why do we need. So instead of the storage, we can add you can easily add let's say instead of this adding the storage right over here, what you can do is we can make an array right over here. So I will let you know afterward. Let's say just first test these two call data and memory, compile them, and again deploy this, and now we have to essentially look up the gas fee, so which one takes more gas and all kind of stuff. Deploy. Now once you deploy the contract, you will see these are the two functions. So this is the call data one, and this we have right over here is the memory. Now I will already tell you that memory essentially holds your local variables defined inside the function. These are not permanent, this is permanent, and this will take less expensive for gas, right, as compared to storage, right? So we have call data, so we know that call data holds your data essentially for the long term, right? So that's why we need to add that. So let's say add a string of my name. Let's say add arrays of 1 2 3 4 6 7. So once we have both of them, let's just essentially transact this and just try to expand the call data one. So if you look at the gas essentially is this gas, right, for the call data one, and just essentially call them gas for call data function, because we have this. I think it's in Gwei, so that's why I just add gas. And again let's say transact this memory one, and now this memory one essentially transacted, and you will see that the gas for this is essentially more expensive, right? This is essentially more expensive gas for memory, because we have this gas, right? This is essentially more expensive than the call data, because call data stores its permanent, and then it's not stored permanent memory, and hence the gas for this is huge, or let's say a bit more than this one, right? Now let's say use memory. Let's say I will let you know how you can use memory, how you can use storage, sorry, in this Solidity. So let's say just remove these things just for now, right? And now what we need to do is we need to send. Now let's see the implementation for your storage, right? So for the storage thing, let's say make another contract. So then make contract for, let's say, main storage, and this contract would essentially, we can say this contract takes a int. That int is going to be a number. It's going to be a public one and going to be a number, right? So then let's say make a function. Let's say make a function. This function essentially just make it a number, right? So yeah, so we need to public right over here because we want to, okay, we want to view that, right? So you have this function of numbers or public, right? Then we need to essentially push the, let's say we have this numbers dot push, and we're gonna pushing the number 1, and then let's say make a numbers dot push, and this should be your 2. Cool. So yeah, make sure that you add a semicolon at the last so that you can easily recognize that. So next thing which we're going to be using is, let's just essentially create a new instance. Let's say make a int, okay, let's say make a int of let's say storage, right? This will be storage, right? And the storage is, let's say give it a my array, right? And this should be equals to the numbers, right? Then again, let's just add the value to the final index with this new index. Let's say we can add this my array of index 0. Let's say index 0 is equals to, let's say, 0, right? So what we does is we are essentially storing the index of 0 as 0, right? So now let's again compile the contract and delete this one, and so we have these two storage. Let's say add this main storage and deploy this, and you will see, let's first essentially call this, and yeah, every time if you look at the numbers, like this number 1, so in Solidity or in Remix itself, the buttons which have this brownish color cost you gas, but this kind of button doesn't cost you gas, right? So if you look at this numbers, right, so once we call the numbers function, and if you look at the expand the transaction list, and if you look at the gas, right, so gas fee, yeah, so gas fee is here. So the gas fee is huge, right? So let's say gas for storage is close to around this, right? This is the gas, right? So if you compare that with the memory and then with the call data, storage takes a lot of gas, right? And yeah, that's everything for now. Let's make a simple contract in Solidity. Now let's make a contract by using this contract keyword of simple contract, okay? And inside the simple contract, what we want is we want to add a string of public, and let's make it a name, right? So we have this string right over here, which is of public name. Now let's make a function to set to essentially set the contract. So let's say this set function take a parameter of string underscore text, so, or even say we can also say underscore name, right? So that would be more renewable. And now if you look at this, I essentially use underscore right over here because of name conclusion, because if I just use name it will throw me an error. That's why I specify underscore right over here. And I also need to because now we are setting this, so we need to add a call data. You can also, I would say you can also add memory, but memory would be more I would say take more gas, so that's why I just specify call data. Cool. So now let's add external right over here, external, because we want to call this function from an external user, that's why we specify this external. And then just name, just give this way, right? So now we essentially in the set function take a parameter of string and get the call data of underscore name. It's going to be a external function, means anyone can call it from external source, right? And let's say make a function now to get the essentially name. So this get function is going to be an external view returns of string memory return X. Now what does this view mean? So I already specified that if we want to get the state variable, so we need to use view in our contract, and now we use external because we want this to be get external use. So now that's why we specify this as external. Now let's say we can specify it as a name because we want to get this public string, so that's why I specify this name. Cool. So now let's just compile this contract. I'll compile this contract and now just delete this and then deploy this, expand this contract. Now you will see the set function, get function, name function, right? So first we need to set, then we can able to use this get and name. So now if I just click on this name, it will show me nothing, or it's just empty, right? It show me nothing. Same for the get, right? So if I just let's say if I just add a string of something, let's say if I just add a string, let's say what can I add, say my name, and just click on this transact, and if I click on this get, it shows in the string. Same for the name. Cool. That's how we can use how we can make a simple storage in Solidity. I will see you in the next video. Now let's understand what are view and pure function. Just clean everything up, and now the view and pure function are essentially can be, so now functions, just for now the functions can be categorized into three types. They add a comment right over here, three types of say functions, keyword, right? Functions, keyword we can say in Solidity, right? And the first one which we have right now is essentially gonna be the first type has no keyword. The first type has no keyword. The second one, as we know, is gonna be a view function. The third one is essentially a pure function, right? Now when I say no keyword, right, so if you look at any of the file, let's say if you go to this memory and storage.sol, you will see right over here we don't specify any view type, right? So now view, there is nothing, and not at view and not anything else right over here. So that is an example of your no keyword function, right? Now the view function consists of this keyword known as view, and the pure function consists of this keyword known as pure. Now let's do some sort of example right over here. Let's say, now first thing to understand what are side effects. Now side effects are let's take an example of, let's make a event of name right over here, and now let's make a function of update, and this update function is again going to be a public because we want to do that. Now let's say make a event right here. So now we don't make an event, let's say make it a string, because yeah, so just make a event of, let's say x is equals to, let's say 10. Now what we are going to be doing is we are updating this x value to, let's say 10, let's say 90, right? So this is not a side effect, but if we are updating the name value to, let's say we are updating this to your name, now this is a side effect, right? So we can also, let's say for the simplicity, add a event right over here and name this as age, and let's say add a age, and let's say make like 89, right? Now this is an example of a side effect, and this is not a side effect because we are just updating it inside a function, right? Now we are updating, now we are using, now we essentially what we are doing, we are already declared a state right at the top, and this now we are updating it inside a function. This is an example of a side effect. Now let's move ahead and talk about some other view functions, right? Let's say, so just take an example of view function right over here, right? So what is the main use case of view function, right? So the view function, we can understand that view function reads the state but does not write the state, right? So the view function essentially reads the state but does not write the state. Let's take an example right now. Let's say, and yeah, every time you read the state it would be free, but once you want to update the state you need to pay a gas, right? Because you need to perform some sort of action, so that's why you need to pay a gas to perform that action. Yeah, so that's why reading a state is free. So I will let you know what about the gas and all kind of stuff later on. Let's say, okay, let's say make a function again, function of update, let's say not update, get age, right? And we are going to be making this function, so we need to read the state. So let's say return age, because what we're going to be doing is we're going to be just returning the age. So this is an example of a view function. So first thing first, we need to specify public view, because this is now we are reading the state, right? So now we need to specify view keyword right over here. Then we need to add a returns, because we are returning values. Let's say add a event, because it's a event, that's why we have a event right over here. Cool. So this is an example of a view function. So just in case if I delete this view and compile this, so what is happening? So now I need to add semicolon over here and then compile it. Now it's throw me in a warning. The warning states that function states immutability can be restricted to view, right? So it's just a warning. So this means that this means essentially, if we not specify state, is it's giving us a warning that for the code optimization, Solidity always gives you some sort of warning if you don't add view over here, right? So if I just add view right over here and then compile it, and then, or maybe like compile that contract, it's compiled successfully. Cool. So that's how you can essentially use view. So let's say, then what's the use of pure? So as the name suggests, pure, the pure means which is pure, right? So as the name suggests, view also, view means if you want to view something but we need to update, but we do not need to update that thing, that's an example of view. So let's try to link these words with your imagination power. Let's say you can use that. So yeah, so let's move ahead and let's take an example of pure function. Pure function. So the pure function essentially does not read or write the state. So these are pretty different as compared to the view function, right? They neither read or neither write the state, right? So let's take an example right over here. Let's make a function of multiply numbers, right? So let's say we have a uint of number 1, and then we have a uint, okay, sort of problem, uint of number 2, and now let's make it a public and return, it will return us a uint, right? And let's say return a times p. Right, so what this means, instead of adding this p right over, you can add number 1 and number 2. So what it does is it essentially now we already specify the name arguments right over here, and now we're not getting the state, right? So now we need to tell a compiler that neither we are now reading the state, neither we are now writing the state, so we need to add a pure keyword right over here, right? So that's the example of how you can write pure functions. Now we compile the functions, it's compiled successfully. Now if I again deploy this and expand this tab, and you will see this is an update function. Update function, if you look at the update function, it essentially update the thing right over here, update. So it doesn't show anything because we aren't doing anything right over here. So let's say if I get, so let's say add 2 numbers. Let's say we are adding 23 plus 23, call it, just essentially multiply that number, right? So that's how you can use this kind of pure function in Solidity. If you look on this get number, it just get the age. Age we set up right over here. This on this age, it shows us 89. Cool. So yeah, that's essentially everything. So update function doesn't work. That's all about pure and view function in Solidity. I will show you in the next video. Let's understand what are visibilities in Solidity. Now Solidity has a couple of keywords which you can use to specify a functional visibility, right? So what, now first thing first, let's try to understand what is visibility. Now visibility can be understood as that these are essentially a certain type of keywords which are used to access your function, because you essentially put these keywords in your functions, and by putting these keywords someone can access your keywords and do a lot of other stuff, right? So these are categorized or can be categorized into 4 categories. These are of 4 types. Understand each of them one by one. Let's say make a string right now of name, right? And then what I tend to do, let's add a function, and let's say get your name, and we want to access this name right over here. Now first we need to we able to not access the function name right over here. We need to first specify view, because we need to accessing the state variable in our function, hence we need to add view right over here. Then we need to add returns, because this is a string. We need to add a returns right over here, and this returns a string in the memory. Then we can add a return of name, right? So now it's working. Yeah, so now it's giving us if we compile the contract from here, and you will see it's now giving us an error. The error states that you didn't specify visibility in a contract, right? So let's say right now we need to specify a visibility. Now we can write visibility anywhere. Let's say we can add visibility right over here. Let's say if I add public and then compile the contract, now it's compiled successfully, right? So this is the first type of visibility, which is known as public, right? The public essentially means that while we use in public, we can able to call the contract from outside and inside, right? So we can, by using public keyword, we can call the contract from outside and inside. Cool, right? So we can use that to essentially call the contract from outside and inside. Let's say compile this, deploy, and if we look at this, now we'll be able to see this get name function, right? So this doesn't return anything because we haven't specified anything right over here. If I just say right over here, let's say my name, and the compile the contract, and compile this and deploy this again, and now if I expand this, see, now it's giving us a name, right? So hence we can specify, or we can essentially use public visibility, functional visibility in our contract. Now this is the example of first. Let's say if I make a private right over here, right? Now private is essentially so when we use private is also another type of visibility in your Solidity. It's essentially the most restricted visibility, and only can be called from inside the contract. We can't call it from outside the contract, right? So let's say if I make this private, right? Let's say add most restricted right? It's the most restrictive visibility, and we can able to call this from can be called from inside. Let's say let's say we can add can be called from inside the contract, right? So we can call it from inside the contract, but no outside, not from outside the contract, right? So yeah, so we can use that from this. And now if we compile the contract and then deploy this, and if I expand this, we will see, if I just expand right over here, we will see there is nothing function, there is no function right over here, right? Now when I say internal, when I say essentially from inside the contract, we can just use this from inside the contract, right? Now this deploy variable, now this deployment environment is not an inside the contract, so essentially the outside contract development environment. So the deployed contract can be visible as an external host, so hence we aren't able to see a contract right over here, right? So that's the use case of a private keyword. Now let's move on and understand about external. I will let you know about this internal afterward. Let's say first thing first, let's move on and understand what is external. Now external keyword can be called from so let's say, where am I? My keyboard is always going to die. Yeah, so the external keyword, so now let's say expand this thing, Yeah, so if I remove this and add an external keyword, right, if I use external keyword, the external keyword can only be called from outside the smart contract, as the name suggests. We can only be able to call it from outside the contract. Now then, what's the difference between any other? So if I also calling this from outside the contract, then what's the main difference between public and external? Now when I use external, right, now external keyword, when I use external, we can't call it inside, right? It only be callable from outside the contract. Let's say I can even add a line over here, can be called from outside the contract but can't be called from a inside contract, right? So that's how we can use external keyword. And let's say if I just deploy this, it's work the same. Let's say if I deploy the contract, we will see now we're able to see this get name, and if I expand this, we will be able to see this my name right over here. Now the public keyword can be called from inside as well as outside, right? We can easily call it from inside and outside. Now when I use external, if I were try to call this internal function again, let's say make another function, of set your name, and let's say add a string right over here. This string is going to be a memory of underscore name, and let's say add external keyword right over here. And then if I now specify this name to our name, now you will see, okay, yeah, so we need to specify view right over here because we accessing the state, and view, that's working fine. Now the main problem right over here is essentially so now if I call this if I just essentially call this get name function, just okay, now you will see there is an error that states that cannot be called, right? So get name is not yet visible to this point, right? Because this is essentially essentially external function which can be called from outside the contract, but we can't call it from inside. We can't call it in the function. Hence, that's the usability of this contract, usability of this keyword. Let's move ahead and understand about this internal, right? Now internal type, internal visibility is essentially the same. Let's say I will let you know about this internal right now, that the internal one, let's say we can access it by using this internal keyword. Let's say add internal, right? And let's say add a internal keyword right over here. Now what this internal meant, that it can only be callable, it can only be called from inside the contract, and we can easily inherit this internal from so if we have multiple contract in our folder, in our file, we can easily inherit from one contract to another contract. What's the use of inheritance? Now inheritance is essentially used to extend the functionality of a contract. Let's say I will let you know about this inheritance by taking this example. So this is essentially an example of inheritance. Let's say we have this contract A that right over here, and now we can able to use this B contract as A contract, right? So we can use this B contract as an A contract by using its subparts, right? So we can also access the C contract as a contract functions, right? So we can use that right over here. Cool. So that's how we can use internal keyword in our contract. Let's say we can add specify right over here. Then use that. So these are the three types, or we can say variables, visibilities in Solidity. I hope that this video makes sense. Just smash the like button if you like this video. I will see you in the next video. let's move ahead and understand about modifiers. Now, modifiers are interesting to understand, and so let's talk about it. So modifiers are essentially a piece of code that runs before and after the function call, right? And so the main problem it tends to solve is it essentially helps in restrict the access for a certain function. So let's suppose you have a NFT collection, and let's say you have an NFT collection contract, and you want the NFT only be mintable by the person first who deploy the contract, and someone else, the persons who aren't using, who aren't able to mint that, they were just throw with an error of XYZ, right? So you can use modifier in that case, and they are essentially useful for restricting the access for certain piece of functions. Let's say we can add that usable helps in, let's say, helps in restricting access for some functions, right? And the next step, which is tend to solve, is it essentially increase the usability for your code, because now you're not using now you're not essentially writing or copying the same code every time again. You are just using a modifier to handling all kind of stuff, right? So it also helps in resolving the problem of gas while you're deploying the contract. So we can say helps in the reusability for the code in the contract, right? So they tend to solve the problem, and yeah, they are essentially good in that case. So let's say let's try to make a contract so that you understand in a more brief manner. Let's say we're taking an example over here, that suppose that you are a contract owner, and you want the certain piece of NFT can only be mintable by yourself. So you want to make a contract that the person who deploy this contract can only the person who have access for this certain NFT, and they can only the person who can mint this NFT. So you want to make a contract in that case. Let's say we can make the person who deploy this NFT contract can only be the first is only be the person who is able to mint the NFT, right? Something like that. Let's suppose and start our work. Let's say make an address of let's say public of owner. Let's say make a bool of can mint NFT, right? So this is a boolean which is essentially set to null. And now let's make a constructor. Okay, let's make a constructor. Now this constructor is essentially setting the owner, whosoever deploy the contract. Let's say I deploy the contract, so it's setting the owner is equals to message.sender. And then let's say make a function of start. It's going to be public. Okay, now we essentially want to so now we can able to access this by using require. So we want whenever whenever person start this contract, we want to set can mint NFT is equals to maybe like true, right? So now it may throw an error, or maybe like say we can even add a require statement right over here that makes more sense for contract. So let's say add a require statement that if the owner is equals to message dot sender, then you're good. But if you don't, then throws an error that you don't have access to mint this NFT, right? So this is a simple program that essentially first this constructor will run, and whosoever deploy the contract is essentially the owner, and the owner who deploy the contract is able to mint the NFT. So it's basically a simple contract. And now let's say compile the contract. So we need to add this statement then the contract. Now it works fine. Compile it, it's work fine. Now we just let's say I am deploying this from this account. Deploy, make this okay, so to see this. Let's say deploy the contract, and let's say the star. So if I click on this owner is the person who deploys the contract. Let's say in my case this is the owner who's ending with DDC4 account number, ending with DDC4, and let's say if I click on this start, it essentially successfully runs the transaction. Just in case if I let's say change my account and then essentially start the let's say run this function, then it will show me an error. The error states that you don't have access to mint this NFT, right? That's how you can make a simple function that essentially test and give you an error. And this is essentially useful to restrict the access for certain functions. Let's say in our function, or maybe like if you're making multiple functions, we want to repeat the same line. Let's say if you're making function of let's say we have this multiple functions, right? So we have this multiple functions that do the same task. They essentially search for the message.sender and they throws you an error, right? So this is essentially a lot of code repetition in your contract, and that shows an impact on the gas fee. So to optimize the contract, to make it more usable and just make it more appealing, we can remove this code repetition and try to make a modifier right at the top. Let's say we can, instead of this line, instead of adding this require statement right over here, we can make a simple modifier that essentially say made a modifier that modifier essentially just make it like only owner, which means that only this owner can able to mint this, have this access to this function. Let's say we make the same statement and copy right over here, and just remove this extra spacing right over here. Yeah, so we have this simple modifier right over here that's the same thing, and we are using this right over here. And now once we do that, we need to also able to add this thing. So even we can add this at the top, means by adding this statement, this essentially gives the access to the person that they can easily run the code from afterward. Let's say we have this, and now it's compiled successfully. Now we can able to give it a modifier. Let's say if I copy this right over here and paste it, now this behaves the same way. If I compile the contract and again deploy this from this, and it's showing me the same thing. And let's say owner is me, start successfully, and then if I change the contract and then start it throw me an error stating that let's say, hey, you don't have access to mint this NFT, right? So this is essentially usable if you have multiple lines of, if you have multiple functions. You just need to copy this. So if you have multiple functions, let's say if you have this multiple function, you just need to copy this only owner function instead of adding this entire line again and again, right? So that's how you can able to optimize a contract and use this kind of keyword whenever using use modifier. In this video we are going to be talking about how you can build your first smart contract and deploy it to Ethereum network so that anyone can go ahead and test a contract and try to interact with a contract. So in this video, we will cover everything about how you can deploy a contract, how you can write a contract, and eventually make it out so that people can able to use it and just try to interact with it. Cool. So first thing first, if you open up your any browser, let's say I have my Firefox over here, and make sure that you have Metamask installed. This is basically a wallet which you are going to be using to send a transaction in between, and make sure that you have. If you don't have installed this, I had a video on this, so you can just watch that video. I will link that video in the description and just view that video, how you can install that and all kind of stuff. Then we are going to be building a smart contract that is written in Solidity. So eventually this language is the main language which we are using to write a contract on Ethereum network or any other network which are built on Ethereum. Now first thing first, just open up a terminal so we can start coding. First thing, just open up terminal, and let me just make it the size big so you can able to view it. Cool. So now we can be making a new directory. Let's say we are in just home. Let's say cd into desktop, and just make a new folder. Let's say contract. Cd into this contract. And just open up with code. Once you open that with any of the Visual Studio Code, any of the code editor, make sure that you have let's say so we are going to be making our first contract. Let's say make a new file, contract.sol. Cool. So now let's make a contract. So we're going to be making the simplest contract today. It should be a simple counter contract where people can able to listen to the contract, listen to the count. They can increment the contract, they can increment the count, and they can also decrease the contract count by 1. Cool. So the very beginning you should have a comment at the top of your file. Let's say we are going to be using spdx license identifier, which is MID. This is necessary when you are deploying a contract on open source. Every time when you deploy the contract on like since the blockchain is visible and you can just view the code online, you should have this above, I would say, a certain comment. This signifies that your contract is eventually identified by a certain license, so that people can able to it just decreases the chances of copyright if you have a certain complex contract, and you want to avoid people to copy a contract. You can just use this. And if you not want to deploy a contract, you can just, instead of this license identifier, you can just use unlicensed over here. Cool. So now once we write the comment, you should be, then the next thing which we are going to be using is we need to specify the version of the file which we're going to be working on. Let's say we need to start with the pragma solidity, and just add a our code and just use 0.8.7. Cool. So now we specifying that this is the current version of the contract which we will be using. This power sign indicates that we are okay to use if this 0.8.7 is just changed to 0.1, 0.2, 0.3 or 0.14, right? This is the main word, this is the main keyword, because there's a lot of outbreaking change happening in the version of this compiler. That's why anyone to whom you talk to, they always tell you to use this quotation mark. Cool. Now the second thing which we're going to be using to make a contract, let's say make a contract keyword. These are the keywords. This is the keyword in the contract. Let's say we have a contract of, let's say make it a counter contract, and we have this contract of counter, and we want to make a uint of 256, and just make it public and just make it like count. We are declaring a non-negative integers, of name count, right? We can also say, we can also write this in this manner. Let's say 0. This count is equals to 0. This also the same as writing this, right? Because initial value of this UN256 is always initialized to 0. That's why we are okay to use this without writing equal to 0. Cool. So now let's make a function. To, let's say, get the count, and let's say just make a function of get count, and we are going to be making it as a public function of view, and going to be returns. It's going to be returning UN256, and then we are going to be returning our simple count. Cool. So what it does, this count returns the value of the count, the current count which we have. So every time a person runs this function get count, it will just simply returns this value of get count of the current count which we have right now. Let's say this is a basic function, and yeah. So now after that we can make another function to increment the count value. Cool. So let's make a function. Let's say increment, and let's make it a public function, and let's say count is equals to count plus 1. Let's say plus 1. Cool. So this increment function add another count in your certain count variable. Let's say first, let's say over here we have a count initialized to 0. When a user runs this function, it just add one count to this. Now this count is equal to 1. Now this is a simple function. Now let's make another function of, let's make a function of, let's say, decrement, and let's make it a public function, and let's say count is equals to count minus 1. Yeah. So this is essentially a function to decrement the count value. Cool. So we have this increment function and decrement function. So we almost done with the contract. This is the simplest contract which we have ever made, and now it's a time to deploy the contract on Ethereum. So you can use a IDE. So I can even compile this code on my main on my PC, but sometimes if I just deploy the contract, it's not that interactive, right? So even I can just say, let's say if you have a SolC installed, let's say SolC is a compiler which is so you can eventually just search for SolC Solidity, let's say SolC compiler install. You can just install the compiler from here. Yeah, it's the simplest compiler which is installed by npm npm by install globally, and yeah, cool. So every time we install, let's say if you install a SolC, you can let's say SolC version, you will see the current compiler is almost like 0.8.14 plus, right? So yeah, we can run this file. Now you may have aware of, every time we run our Solidity file, it compiles into bytecode, and it just goes to EVM. It just talks to EVM in two languages, in just two components. We can say the first component would be the bytecode, and the second one is going to be the ABI. The bytecode is essentially in hexadecimals. It is long strings. Let's say I just show you. Let's say we have the sol C. Let's make another comment so you can understand it more clearly. So we have our contract converted to bytecode and ABI. Then it goes to EVM. Yeah. So if I just run sol C and just add your file, let's say my file name is contract.sol, and let's say bin stands for the binary which we have. So once I, let's say, press enter, you will see this is the binary. These are the long string which are just the hexadecimals of a current contract. These are the binary code which then goes to EVM, and then it just then it just shows the output by using ABI and your binary code. Let's say this is the binary one, and we also have, let's say, sol C, and let's say we have our ABI. This is an ABI, and you may have aware of ABI is a set of instructions that when ABI and binary bytecode give combined, it just gives given instructions to the EVM that these are the files which code is going to be have, and this is always in JSON format. So let's say we have our inputs, which is a name, and count, which is output of this internal type of this. Let's say these all are in a JSON format. Let's make it more interactive by copying the same code and using it on Remix. So Remix is essentially an IDE which is provided by Ethereum itself for developers who want to test their code, who want to write their code, who want to compile their code, and all sort of stuff. Let's say you can just go on to remix.ethereum.org. This is the main website for any other Ethereum IDE development, if you can use it. So once you open the website, yeah, so the website looks something like this. So make sure that you install, let's say we have a workspace of Ethereum project demo, and you can just make a new workspace. Let's say just click on this workspace, and let's make a workspace of contract, and okay, and just make it like blank, or let's make it a default. Let's say we have a contract demo, and just click on this OK. It will then create a lot of workspaces for us, so we don't need to worry about this test script and all sort of files. We only need to worry about this contract folder. Now just delete everything. Let's now just delete everything, so we can start with the very beginning. Let's delete everything from here, even the contract one. Let's delete it, and let's delete everything for now, from the script folder to your test folder. These are the folder which is used while testing, if you want to test your contract on this remix itself. So just make a folder that is contract, and inside this contracts, let's make a file of dap.sol. Now the code which you copied from here, just paste that code over here, and once you paste this code over here, let's say, yeah, it looked a bit like this. The same code which we have written over here, and we copied it right here. Now let's say just open up this over here. So there's a third icon in the sidebar, this named as the compiler which we will be using. So the current compiler which we have over here is 0.8.7. so just it just automatically detected your compiler for your file. You don't need to worry about that. and then just click on this compile button, and now it's compiled. And again you will see there's a two sections over here. There's a bytecode and there's an ABI. So previously, if I compile on my desktop, you will see the binary code looks a bit like this, right, and the ABI looks a bit like this, right. So if I compile this, if I just copy this code from here and just show you over here, let's say make a bytecode.txt and paste it over here. This is essentially the ABI. I just copy the ABI. So this is the ABI, and the ABI is looking the same as which we have right over here, right. So ABI is essentially a set of instructions which are written to the contract, which then the EVM understand, and then they just basically execute the code. So this essentially written in JSON format. We have our input, we have our name, output, etc. And just it's basically the same. If you just copy the bytecode, it's almost look kind of same. Let's copy the bytecode, and you will see the bytecode. Now over here, the bytecode is encoded in your object, right. This is an object. We also have this function which is empty for now, so you don't need to worry about this function, debug data, this link references and map source. Just look at this. This is our bytecode, and this is referenced by this object keyword, right. So that's all about this. Let's move on over here. Now since we have compile a contract, we also test it. We don't test it yet, but we just tell you about the bytecode and the ABI, and we also compile the contract. Now it's a time to deploy the contract. Now over here you will see there are a lot of things going on over here. First, if we go this if we just click on this I would say deploy and run transactions, you will see there's this function, there's a section of environment, right, and this environment consists of this JavaScript virtual machine and JavaScript virtual machine of Berlin, right. So this essentially means these are the two private blockchains, and so if I just click on this JavaScript virtual machine, this is essentially a private blockchain that is essentially not controlled, it's just sitting in a certain place like London, and this have this random accounts, right. So they have this random accounts of maybe like 10, and every account consists of 100 ethers. These are obviously the fake ethers, it's not the real ethers, but every time when you run the contract, and if you want to just make it the transaction much more faster than anybody else, you can use this virtual machines to just test out a contract. And just for now we are going to be using this injected web3. So injected web3 is essentially so when you click on this injected web3, you just open up your Metamask. This essentially means you need to inject your web3. So we have this web3 browser which we have right now, which is Metamask. So we want to integrate it into our this deploy and run transaction environment variable. So you can just add your password and just click on this unlock. So once you unlock your account, it will add it over here, right. So we have this account, and you can use a chain, which is essentially we are going to be using Ring-B today. So Ring-B, just move on to Ring-B. So Ring-B is essentially a testnet for Ethereum network. So it's just the same. If you want to deploy a contract on Ethereum mainnet, you can just select your Ethereum mainnet from this networks tab, and you can just deploy from here. I don't have much money right for now, and don't want to deploy, I don't want to waste my money on this, so I can just using your Ring-B testnet for now. But it's just the same. If you want to deploy on this, you can just choose that, and it's just work the same. And I also have very less ether right now, right. So you can use any of the faucets. So right now we have a lot of faucets to get the test ethers. Test ethers are essentially the ether which you can use to just test out your transaction. Is it working on the certain machine or not? So let's say you can use test rank b, let's say rank b faucets. You will see the famous faucet over here. So I recommend to use faucet.chainlink.inc. This is essentially the best faucet. You can just use it for now. It is fast and it is also reliable. It is maintained by Chainlink organization. You can just use it. So just select your wallet account and just select the Rinkybi testnet, and you are just good to go. We only want the test ether as for now. We don't want link. So let's say request a transaction. It's just initiated to this hash number, and once that done, you can easily use in our Rinkybi testnet. Yeah, now it's completed. So now we can use. Now we'll check. If you see your wallet, it's updated. It just updated to 0.1 and this ETH. Cool. So now what we can do, we have this gas limit. We also have this Gwei. This is just a unit for how we measure gas. So you don't need to worry about this from now, just for now. And now just click on this deploy. So let me just make this terminal a bit bigger. So just click on this deploy. It's initiated this progress, and you will see this pop-up will open, and it will ask you to pay some sort of gas fee, and just click on this gas fee and confirm. You can also view on this ether scan, Rinkybi ether scan. So this is our state. It's still pending. So let's say you will see another alert that says this transaction has been completed. Once the transaction has been completed, now it's confirmed. So cool. Now it's confirmed, and you will see this this window will pop up. This is essentially the output. It generated the API and the bytecode, and that give us this this good looking deployed contract, this thing, right? So let's just make it small. So yeah, we have this thing. So over here you will see we have this count. The count is set to go over here. Then this function that's same just to get the count, and if I can just click on this count button, it's initialized to 0 because we don't have any value. I already said that if this value is initialized to this, it's just mean this count is equal to 0. Then if I click on this get count, it's just also 0 because it's just running the count value, and this just initialized to 0. It's also a 0. Then if I click on this increment, you will see the count is increased by 1. Let's say if I click on this increment, it will ask you to pay some sort of gas fee. So let's say confirm, and you will see it increased to 1. Yeah, it's confirmed, and you will see now it's increased to 1. Now we want to make it the contract bit more usable. So for that we want to deploy. So if we just click on this link, and now this is the link at which we deploy the contract, right? This is our account, and this is the address for the contract. So if we click on this contract, you will see we have two methods which are just called right now. First, the creation of the contract. Then we have this right now, which we just use to get the increment value for a contract. Let's say over here we want to make the contract verify and publish. Let's say we want to verify a contract. So for that, you need to publish the source code for the contract. Let's say I just show you how you can do that. So if you click on this verify and publish, it will open up this pop-up. Now you have to select your compiler. So we have a single page file. So since after that, just open up a compiler version. So we are going to be using 0.8.7, which we have over here. Let's say 0.8.7, and we are using MIT license. Cool. So just click on this continue now, this window will pop up. It will ask you to enter your source code. So just copy this code and paste this over here, and just you don't need to fill this details of ABI encoder, it's not needed right now. Just click on this I'm not a robot, just verify and publish. It's taking a bit time. Amazing, now it's done. Now if we go to a contract, let's say we have this contract right now, you will see now it's published. Now it's check to, you will see this check mark over here. This means now the source code for this contract is verified. Now we can easily write and read a contract from here. Let's say this is our source code, and this is our contract by which we can read the contract, and we can also write the contract. Cool. So now if you click on this count, it just initialized to 0, as we all know. It's set to 1 because I initiated the request over here of increment that set the count, the value of the count equal to 0, equal to 1. That's why it's set to 1 right now. But if you don't do that, it is initially set to 0, and this will also show us 1 because this both are same functions. Now if you click on this write contract, you can also write the contract right now. Let's say just click on this connect to web3 and just connect your wallet. Let's say we are connecting our Etherscan. It's asking for some sort of warning. Just click on OK. Now it will open up a pop-up, and then you need to confirm the sign in signature, and then it will just connect to this site. Since after that done, you can use this increment value. The increment function states it just add 1 to a certain value. Let's say if I just click on this increment, it will open a pop-up. Here we go, and this pop-up is essentially ask you to pay a gas. Let's say I want to increase a gas so that the transaction would just initiate so fast. Let's say just select to the high, save, and just confirm it. Once that confirmed, you can also view your transaction hash over here. You will see it's pending. Yeah, it's pending. Now it's confirmed. Now once that confirmed, you will see just click on this read contract and refresh the page. You will see it's turned back to, now it's turned back to 2. Let's say now it's turned back to 2 because we increment the count by 1. Now it's 1 plus 1 it equals to 2. That's why it's turned to 2. Now you can also decrease the value for a count. Let's say click on this decrement, just write the contract. We need to connect to web3. Let's connect to web3. Enter your web3, decrement the count. It will open this pop-up, and you will then easily, now it's initiate the transaction over here. You will see it will now decrease 1 value from the current value of count, which we have 2. So 2 minus 1 is equals to 1. So that's why now the count is set to, now it's success. Now it's confirmed. So we'll go, now it's confirmed. Now we just click on this transaction and just read contract and just refresh this page. You will see this now change back to 1. Cool. So now contract is working absolutely fine. This is the first video in which I just deploy the contract. In the next video I will just show you some sort of advanced concept which you can do from this contract. You can just initiate this contract to your main website and let people to just use from this from your website itself. Cool. So that's all for this video. Thank you.